welcome back. So I hope you enjoyed the lab that you did yesterday. We are going to be moving on into acids and bases. I know that doesn't really fit with covalent compounds, but we wanted to go ahead and get that in with an easy chapter because when we get to the next chapter over chemical reactions, we're going to have to deal with acids and bases. So we wanted to make sure that you understood how to name those as well. So talking a little bit about acids, have you ever been stung or bitten by a fire ant? It is incredibly painful if you've ever had that happen. So ants can give off painful stings when threatened because the ant species is called formicines, and they have poisonous glands, and they produce a venom containing formic acid. So in all actuality, when they bite you or sting you, they're injecting you with formic acid, which burns. Okay, it'll turn red, and it's very painful because they're actually putting acid on your skin or inside of you. So just to give you a little idea of what some acids, and that insects actually do have acid that they can use when they're threatened. Okay, so that was just something interesting to know. Now, you'll want to go ahead and copy down these rules. Okay, there's 3 rules when naming acids. The first rule is when the name of the anion, okay, ends in "ide", okay? Remember, the anion is the second element listed in the compound. So when it ends in IDE, the acid name begins with the prefix hydro. So those nonmetals on the right side of your periodic table, okay, such as nitride, oxide, fluoride, chloride, all of those negative anions, when they end in IDE, okay, and you put a hydrogen in front of them, you've now changed it into an acid. Okay, so that hydrogen makes it an acid. Now when you do this, that IDE gets changed to ic. Okay, so you take the IDE off and you add ic, and then you add the word acid. Okay, so when the name of the anion ends in "ide", the acid name begins with the prefix hydro and ends with the ic, acid. Okay, when the anion name ends in "ite", so remember we had our periodic table chart, right? So in that periodic table chart, you have all of your polyatomic ions that either end in "ite" or "ate". So in that box are your polyatomic ions. So if the name of the polyatomic ion ends in "ite", the acid name is the stem of the anion followed by OUS. So if I had sulfite, which is one of my polyatomic ions, I take the "ite" off and I add OUS. So now sulfite becomes sulfurous acid. Okay, so anytime you put a hydrogen in front of a polyatomic or a nonmetal, you have changed that compound into an acid. Okay, now the last rule is if the anion ends in "ate", like sulfate, you're going to change the "ate" to "ic". So it's sulfuric acid. Okay, so if I take a hydrogen and I put it in front of sulfate, it's going to be sulfuric acid. What if I had nitrate? Well, nitrate becomes nitric acid. What if I had nitrite? Nitrite becomes nitrous acid. So as you can see how that happens. Now, an acid is a compound that contains one or more hydrogen atoms and produces hydrogen ions when dissolved in water. Acids have various uses. So I thought this was kind of, because most people think of acids as something, you know, it burns, it stings, it melts things and does crazy stuff and it disintegrates things. But I thought this was a nice example that you could see if you like art, okay, to create designs such as this on glass, okay, this is called etching, right? So you can coat the glass with wax, and the design is drawn through the wax. When the glass is dipped into hydrofluoric acid, the acid etches or eats away the glass wherever the wax has been removed. So you could just take a square piece of glass, dip it in paraffin wax, melted paraffin wax, put a coating around it, and then take just any kind of tool, some art tool, and etch in your design, okay, and then wipe it off, and then dip that whole thing in hydrofluoric acid, pull it back out, and then you would have your glass etching. So that's just something neat to look at if you were into different types of art. Okay, so here's a summary of your 3 rules. So remember, if the anion ends in IDE, okay, such as chloride, you add the word hydro, the stem of the name, and then ic acid. So it would be hydrochloric acid, okay? If it ends in ite, such as sulfite, you add OUS acid. So it becomes sulfurous acid. And then the last one, 8, nitrate, becomes ic, so it's nitric acid. So that's a summary of the 3 rules. Now, let's do some examples. So HCl, so if I look for Cl on the periodic table, I would see that it's chloride. So if it's ide, remember you put hydro and then add ic. So this would be hydrochloric acid, okay? The next one, ClO4, that's a polyatomic, okay? If I go to my sheet, okay, and I look for ClO4, I'm gonna see that it's perchlorate. So perchlorate, 8 becomes ic. So this would be perchloric acid. Then I have HI. I is a non-metal, it's iodide. Remember, if it ends in ide, you put the hydro and add the ic. So this would be hydroiodic acid. H2SO4, okay? SO4 is a polyatomic, it's sulfate. So 8 goes to ic, so that would be sulfuric acid. Next you have H and S. S is sulfide. So ide, you get the hydro and add the ic, so it's hydrosulfuric acid. Next is CN. Now that's going to be an exception because remember how we talked about ide? Well, if you go find CN on the polyatomic chart, you'll see that it's an ide, right? So ide gets hydro and ic. So CN is hydrocyanic acid. And then the last one is CO3, which is carbonate. 8 goes to ic. So carbonic acid would be your last one. So as you can see, these are all examples of how you would name certain acids. Okay, now bases. What about bases? Bases are super easy because they are named in the same way as other ionic compounds. The name of the cation is followed by the name of the anion. Sodium hydroxide, which is NaOH, is a base that is used to make paper. They actually coat trees with it and they use it to make paper, okay, that you use every day. Cleaners and soap contain sodium hydroxide as well. So we use those to clean our body and we use those to clean different things in our house, okay? Now, what if I wanted to write the names for the following bases, right? So NaOH. So what is Na? It is sodium. And what's nice is mostly all of your bases are going to have the OH, which is a polyatomic, and it's a hydroxide. So OH just means hydroxide. So for this purpose, sodium hydroxide would be the name for the first one. Well, now all I'm doing is changing the first metal ion in the compound. The OH is going to stay the same. So now I just got to look for Sr, which is strontium. So it would be strontium hydroxide. Now, NH3 is kind of a tricky one. It is a base, but it's not normal the way most of the other bases are. So NH3, I'm just going to go ahead and tell you, is ammonia, okay? Household ammonia. And then the last one is Li. So you go and you look for Li, and it's lithium, and it would be lithium hydroxide. So see, very short lesson today on looking at bases. And we're going to do the formulas the next day, okay? So tomorrow we'll be doing or learning how to write formulas of certain acids and bases, okay? So you should have an assignment following this lesson where you're going to be writing the names of common acids and common bases. I hope you guys have a good day.